Here, you can see this chapter. You can see we finished the replication. This part you understand where begins the replication. And the DNA damage and the repair and the recombination. This chapter tells us the DNA replicated and the DNA under the difficult condition face the physical factor, face to the chemical factor, face to the biological factors. The DNA sequence, the base, the nucleotide may be destroyed and changed. And certainly, the DNA damaged and the mutation at that times can be repaired. And from today, we began to study the transcription. Maybe some students feel this part already we finished in highest middle school. But my students also seem to the study about the replication, the transcription also. Through this chapter, we studied, you can see, furthermore, understand the every step. For example, where beginning the transcription. And the process, what kind of the factors, what kind of the enzymes take part in the transcription. Okay, and now you can see from this PPT, you can see from this figure. The red color, this string, means synthesized RNA. You can see the blue band, the blue string, it is the temperature DNA, the DNA helix structure. And from this here, we see, you can see the nucleotide, you can see, according to the base pair, you can see at the times, RNA polymers catalyze and synthesize the RNA according to the base pair. And here, base pair different to the DNA paired with DNA. Here you can see U paired with A paired with T, G paired with C, C and paired with G. So, and another thing to pay attention to, at that times you can see only one strand act as the temperature and directed to synthesize the RNA, and another strand don't take part in and don't directed to synthesize the RNA. Okay. We studied, you can say, what is the transcription? Transcription, it is the process of the synthesized RNA with DNA act as the temperature. And the DNA we lose is the deoxyribonucleotide sequence. And RNA, it is the nucleotide. Different. But all of this, it is the nucleic acid sequence. From here, you can see the figure, you can see. At that time, so you can see the DNA. It is the double helix structure. Only forms the relaxed, the single strand can be directed to synthesize of synthesize the RNA. Here, maybe similar to the replication. Replication also you can see several kind of the enzymes take part in and make the DNA double helix structure relax. And furthermore, you can see the molecular you can see can be forms the single strand. Thirdly, you can see the double helix structure want to be relaxed, and at that times you can see, and at that times you can see, want to forms the single strand. Here, I think the enzymes take part in the replication. You can see the tuple is the varus, the helix, it is so on. I think maybe take part in this process of transcription. Because I just tell all of you, the DNA temperature must relax and forms the single strand. The simply summarize the transcription. It is the synthesized RNA with the DNA act as the temperature. In fact, here is the clear definition for the transcription. This is the process in which the RNA is synthesized from the full rubber nucleotide, the ATP, GTP, CTP, and UTP, catalyzed by the DNA-dependent RNA polymers, and use the DNA strand act as the temperature. This process we state it is the transcription. Here you can see the replication and the transcription different each other. And here you can see temperature different. You can see replication two straight directed to synthesize offspring DNA and synthesize two molecular DNA. And transcription partially sequence of the one strand, another strand, another coding strand. Don't direct to synthesize the coding sequence. And the source used to synthesize DNA and RNA, you got the different. This you studied in the school, you know it. And another thing is the enzyme is different. Certainly, you can see here. I emphasize all of you the DNA polymerase. DNA polymerase can't synthesize the DNA straight from the beginning. And the DNA polymerase only can elongate the nucleotide sequence. So we started the replication. We learned you can say the DNA replication need the premise. And to synthesize the offspring DNA. Especially for the oxidator fragment, every fragment needs the primer. For the transcription, the RNA polymerase can be synthesized the RNA straight from the beginning. Don't need the primer. And the products are different. You can see the replication produces the offspring DNA, and the transcription produces all kinds of the RNA. And last, you can see, according to the base pair and synthesize the offspring DNA and all kinds of RNA. You can say A paired with T, T paired with C. Since the transcription, you can say A paired with U, G paired with C. Okay, second definition. Transcriptional unit. Transcriptional unit. This is the very easy. You can see transcriptional segment can be regarded as the transcriptional unit, including one or several structure gene, and the upstream and downstream regulatory sequence. We studied the definition of the gene. I explained for all of you. One genes equal to regulatory sequence added the structure gene. Structural genes coding the RNA. And here, from this figure, I list several Chinese words. From the here, you can see the promoter, 启动子 here. From the promoter, the RNA polymerase bonded to here and moved to the positive one, this nucleotide, and begin to synthesize the RNA. Here, beginning to transcription. And another side, you can see here is the termination point. Here, maybe some students think what kind of the sequence it is the promoter. And later we beginning study this part. What kind of sequence put together can be provided the single start to transcription. And another it is the terminations point. Terminator. Here, this kind of sequence meet the RNA polymers. At that times, the polymers stop the transcription. This kind of sequence will give the name terminator. And from the positive one to the under point, this is the transcriptional unit. Suddenly, for the ecological designs, all the times, maybe one promoter later added the structure gene all in one. All in one. But for the practical design, maybe several structure gene under controls by the one promoter, one regulatory sequence. This we already studied in the genes, the first chapter. Here you can see what kind of the difference to transcription. You can see the transcriptional characteristics. You can see the first symmetric transcription. Just what I emphasize about you can see the DNA replicated. At that times, two straight act at the temperature and direct to synthesize the offspring DNA. For the transcription, symmetric transcription. Only you can see all on DNA molecular double straight. One straight can be transcribed and another straight can't be transcribed. Maybe some students study this item. Maybe you think all the times for the DNA coding the RNA, you can say all the times one straight take part in the coding. Another straight low sensor, low usage. Yes or no? No. You can see this figure is very easy to understand. You can see the up straight, you can see 1, 2, 3, 4, 5, 8 promoter, and beginning the 8 genes transcription. You can see down straight, you can see 3 promoter coding the string genes. You can see one genes this direction coding and transcribed produced the RNA. And another straight, you can see the reverse direction coding the RNA. So here, this property, we summarize, it is semi-trick characteristics. And another property you can see. Here listed are two definition. The coding strader, the temperature strader. You can see just with this, the coding sequence. You can see some sequence. You can see coding the RNA, and another strader don't take part in the transcription. Here you can see the temperature strader and the coding strader. You can say RNA can be transcribed according to the base pair in the DNA double strader. The temperature strader also with this, it is the meaningful strader and the worsening chain. Here you can see the down. You can see down this PPT. You can see have the figure. You can see this is the short sequence. You can see it is the large M for fate, the letter. You can say G C A G T A C A T G T C. You can say transcribed and produced the RNA. You can say it is the GCAGUA. So at that times you can see produced the RNA sequence. You can see paired with another strader. So the CGTC ATGTACAG. This is the temperature strader, and another it is the coding strader. Here, former students pay attention to. Don't confuse about these two definition. The coding strader, temperature strader. And another property you can see high fidelity. Maybe we study the proofreading in the replication. For this, you can see the transcriptional fidelity for the transcription of the spatial genes with the fixed stable start point and the fixed end point. And the nucleic acid sequence strictly abide the per-simple base pair. But here, my students, strictly, it is relatively. It is, however, the only base pairs in the transcription is very higher than replication. Because just I emphasize all of you, the DNA polymers have the proofreading function, but the RNA polymers have no proofreading function. If the transcription, the running nucleotide end into the RNA polymers, and that times may be continue and finished. And the third property, highly progressive. What mean? You can see once the transcription beginning, it don't stop until the polymers synthesize the whole RNA according to the base pair, according to the temperature change. If the standard factor may be effect, the RNA polymers is dissociated with the temperature change. The enzymes can't recombine with the dissociated site to synthesize the RNA again. For example, the bacteria still you cut the under the certain condition. At that times, maybe you heating shock. At that times, the synthesize the RNA maybe stop. Maybe this RNA maybe synthesized thoroughly. Maybe it's 300 nucleotide. Maybe synthesize 200. At that times, hitting shock. At that times, the transcription stopped. When you restore the stopped condition, maybe restore to the natural condition. These enzymes want to synthesize these genes are mRNA. At that time, you can see again from the originated point, from the starting point, beginning transcription. Maybe some students think just we synthesize the 200 nucleotide sequence, low usage. This kind of the nucleotide may be quickly in the cells, maybe lysis quickly, no usage. So this property we summarize it is the highly progressive property. For this part, I summarize and totally introduce this property about the transcription compared with the replication. Study this part, and rest 10 minutes we continue to study the process. Thirdly, we divided the pro-radical organisms and the eukaryotic organisms because these two kind of organisms you can say different. And just for the property and several definition, please compare with the replication. Study this part. Rest 10 minutes.
Okay, launch.
Okay, come back.
OK，老师。
Okay. And then also we began to study the process about the transcription. Thirdly, the process for the prokaryotic organisms to the eukaryotic organisms different. So here we divided this two kinds of organisms. You can see, and first we study the prokaryotic organism. How to finish the transcription? Where beginning the transcription? Okay, so the first it is the transcription of the prokaryotic organisms. The first for the prokaryotic organisms, you can see the polymerase. Two kinds of the form. These two kinds of the forms take action different stage. Different stage. You can see Holler is time. The hollow enzymes you can see different to the core enzyme. You can see the composition. These two kind of the forms compare each other. You can see here another one. Status subunit. For the core enzymes, you can say without this subunit. Why? Because different stages take action. So here you can see the whole enzymes. You can see the structure is more condensed. And for the coenzymes, you can see relax. So later we study the process. These two kind of forms enzymes, you can say take action. I introduce for you. You can say because the theta subunit have the good function, can be recognized the promoter. And the other subunit, you can see maybe bonded two together and forms whole enzymes beginning the transcription. When beginning the synthesized RNA, the theta subunit divide from the whole enzyme. Only after the coenzymes finish the after the process of the transcription. Here, for every subunit, you can see the function. You can see theta subunit. You can see recognize the promoter. The alpha subunit. You can see decide which genes transcribed. And beta, it is the catalytic function subunit. Beta primer subunit, you can see bonded with the temperature. So you can see theta recognizes the promoter in the prokaryotic organisms. Promoter, you can see, contains the spatial sequence, the lactive 35 sequence. This sequence recognized by the theta subunit. And beta prime subunit, you can see, bonded the lactive 10 sequence, the TATA box. And another one, you can see another factor, the rule factor, take part in the termination in the periodic ordism. Rule factor, you can see. Also, loss of the it is the release factor. All the times forms the 6-polymer protein can be catalyzed and hydrolyzed ATP. And the helix course makes the new produced RNA strand dissociated with the 3 transcriptional complex. So terminated the transcription. Okay. This 3 PPT summarize the polymerase and the release factor, rule factor. How to beginning, how to finish, how to terminate it. From there, the structure we studied. You can see for the promoter, you can see promoter, it is a DNA sequence. Then the RNA polymer recognize bonding and the studying the transcription. It conserved the several sequence. This sequence is needed, is essential for bonding and the initiations the transcription. And this is the sentence that you remember. The promoter sequence never transcribed. Here we just studied, you can see the here several sequence already studied the very thoroughly. The negative 25 sequence and the negative 10 sequence. And the first chapter we already studied. You can see this sequence, you can see this conservative sequence, you can see have the function. Later the theta factor and the RNA polymerase recognize and bonding and initiation the transcription. This figure we already studied in the first chapter. This in the periodic organisms gave the 3 names. The first negative 10 sequence. Because this sequence, you can see TAAT, this is the conservative sequence. So all the times we also give names, it is the TAT box. This conservative sequence founded by the probular. So we see it's probular's books. So 3 names. All the times buried in the promoter sequence. One of the conservative sequence. Okay. Here, the secondary item, you can say different promoter. Their position are slightly different. Maybe before 2 nucleotide, maybe down label to the positive 1 point. Different promoter have the different frequency of the each base. And another conservative sequence, just with this, it is the negative 25 or 35 sequence. This also we give names is GACA box. You can see this conservative sequence 6 base TTGACA. located about lective 35 point. So we give names. It is the lective 35 sequence. And second, the GACA box. This recognized by the theta subunit of the polymers. The frequency of the H base in the lective 35 sequence of the different promoter are different. The lective 35 sequence is the site of the initial bonding of the polymers. Just with this recognized by the theta subunit. And the nucleotide structure of the 35 sequence determines the length of the promoter. We studied in the genes chapter. We lose with this, it is the lective 35 sequence located about upstream 35 nucleotide before the transcription point. About this English words you pay attention to. These two kind of the conservative sequence is very important. The negative 35 initiations of transcription and recognized by the polymers. And another things, teachers, you just see is the negative 10 sequence, negative 35 sequence. About here, every two conservative sequence you can see located about upstreams 35 nucleotide. About upstreams 10 nucleotide location. About. So here, for the periodic organisms, the interval length between these two sequences have the very important function. You can say interval between the negative 35 sequence and the negative 10 sequence is important for the transcription and regulated the transcription speed. When the length equal to the 17 base pair, at that times the transcription arrived at the highest transcription efficiency. Most probable, this interval length about the 16 to 18. When it is the 17, the efficiency is it is the highest. And another thing you can see, summarize the production of the transcription started more than 90% of the transcription edition site. It is the purine nucleotide. Yeah. And summarize and find this kind of the conservative sequence beginning here till you. It is the originated point for the transcription. Here you can see M means pyrimidine. Maybe it is the TOC. And second, it is C. And third, it is the A. And the four is T. And the later two, you can see it is midine, pyrimidine. And contains this kind of the conservative sequence. Okay, from here, for the structure of the promoter, for the structure of the interval sequence, we study this part, and later we begin to study the holy process of the transcription. Okay, initiation of the transcription in the periodic organism. And first meet the trouble. The DNA, you can see, forms the double helix structure. At that time, beginning the transcription. At that time, you can see the RNA polymerase must be accurately bonded to the start point of the temperature. And second, the DNA double helix structure relax unwinded. So one straight it used as the temperature for the transcription. How to relax is very easy. Simply choose the replication. The topoisomerase, the helix take part in and relax the double helix structure. Here, before we study the transcription in the periodic organism, here, simply choose the replication. I introduce follow you. In order to study more easily, we artificially divided the three stages for the transcription. For the replication, also we divided three stages. Origination, elongation, termination. For the transcription, you can see initiation and second, it is the elongation, and last termination. How to beginning? You can see first we start this one stage. You can see the negative 35 region sequence in the promoter recognized by the theta subunit of the RNA polymerase. And other subunit and immediately and includes and bonded to the promoter and forms the holoenzymes loosely bonded with the temperature. And the enzymes skipped and moved to the negative 10 sequence. And here, TATA books. And easily, the RNA polymerase, you can see one of the subunit, the beta primes, may be squeezed to the double helix structure and make the two straight relax. The RNA polymerase squeezed into the DNA double straight. The length of the chains about the 12 to 70 nucleotide. Steadily, the topoisomerase and the helix take part in the relaxed process. At that time, you can see forms the closed transcription complex. At that times, it is the RNA polymerase and the DNA temperature and forms and bonded together and forms the transcription complex. You can see here. The first polymer reaction finished under the catalyst of the RNA polymers to form the transcription initiation complex. The transcription initiation complex, three components complex forms the initiation stage finished and immediately enter into the elongation. Here you can see. The first step, you can see theta factor recognizes the negative 35 sequence and as the sub-unit of the whole enzymes bonded together and forms complex and closely bonded with the promoter, bonded with the temperature state. At that time forms the two complementary complex and moved to the second step, you can see the whole enzymes moved to the forward to the negative 10 sequence. There makes the promoter begin to relax furthermore and forms the single straight. And here you can see the beta sub-unit, you can see begin to catalyze squeezed into the double helix structure of the DNA. And that times the active center right and the negative one side and recognize the rubber nucleotides enter into the RNA polymers. At that time, pay attention to the whole enzymes catalyze and the two rubber nucleotides bonded together and forms the first new produced the diphosphate diester bond formed. At that time, immediately the theta factor separated from the whole enzyme, divide from the whole enzyme, and go away. Only left the coenzymes furthermore synthesize the left sequence. The theta factor divide from the whole enzyme. This is the initiation factor, initiation stage. 1, 2, 3, 4. 4 important things finished. And later is very easy. My students remember when the theta sub-unit divorced from the complex, the coenzymes was allosteric and the bonding with the temperature was the relaxed bonding with the temperature and moved forward along the DNA temperature. Under such condition, the RNA polymers recognize the rubber nucleotide. And one by one, you can say enter into the RNA polymers. The RNA chains is continuous elongated. At that times, this process we see is elongation. Elongation. Move forward, forward. Move forward and forward. And here you can see the transcription bubble. At that time, you can see the coenzymes bonded with the temperature and forms the RNA. At that time, the coenzymes relax bonded with the temperature and forms this complex structure. You can see forms this kind of the structure. With this, it is the transcription bubble. Here, this contains the DNA straighter. You can see 20 base pair. The RNA DNA hybrid straighter. It is the 82 base pair. And another component, it is the coenzyme. One by one, elongating the RNA straighter. And here, from this figure, from this PPT, maybe some students think, why synthesize the RNA? The RNA straighter, you can see autonomously divide from the temperature of the DNA straighter. Why? This I asked the students answer during the final examination. Why does the RNA straighter automatically give way to the DNA straighter to form the double helix structure, and the RNA straighter divide? Why? Owing to stability. The DNA double helix structure is more stable than DNA and RNA hybrid double strings. Another thing you can see, stability. The base pair, you can see GC base pair more stable, AT more stable, and the is very weak for the AU. And another one is RNA polymers also take action. Later, the RNA straighter divide from the temperature straighter. For the left two stager, one stager for the termination. For the periodic organisms, you can see two kinds of methods. One, raw factor take part in and terminated the transcription. And another one, you can see the spatial sequence. These two kind of the termination. We studied the Friday. Today we stop here. We only study the property about the transcription, and we study the transcription of the periodic organism. Only studies the two stages, two processes, the initiation and the elongation. And for the termination, next time we study that. Next time we study the termination in the periodic organism. And furthermore, we study the transcription for the eukaryotic organism. Okay. Today we stopped here.
Okay, 老师。
Okay.
Thank you, 老师。
Do you have some question?
没有问题，老师。
Okay. Class is over.